So I'm here. My name's Jason Morgan. I'm a technical evangelist for Linkerd, and it's my job to talk to folks about Linkerd and try and convince you to give it a shot and see if it's the right service mesh for your use case. So as part of that, let me just give you a very brief overview. Linkerd itself is an extremely lightweight, extremely fast, security-focused service mesh that is geared exclusively towards Kubernetes, right? So we've been in production over 5 years. We've got a very active Slack channel. I'm gonna ask that y'all, if you're looking at Linkerd, I'm gonna ask that y'all join it, and I'll send you that link in a minute. Lots of stars on GitHub, but if you like the project, we're always looking for more. And we are currently in the CNCF graduation process, and that actually should open up for public comment here in the next couple weeks. So that's it for slides. Oops. Yeah, there we go. That's it for slides. Here is the Linkerd Slack, so I'll go ahead and put that to all panelists and attendees. If anyone is interested, you can join the Linkerd Slack at slack.linkerd.io, and it's a great place to ask questions or connect with other folks that are using Linkerd. So, end of the slide deck. Everything else is going to be demo. So here I have a Civo Kubernetes cluster, just calling it Linkerd ingress. And actually, let me step back. Oh, Ganesh, you're going to get me in trouble with that one. I'll answer that at the end of this this question period. So I've got a 3-node cluster running in Civo Kubernetes, and what I'm going to show you today is how. I'm going to show you how, and I'm going to talk about why to integrate your ingress controller with your service mesh, right? So different meshes implement different functionality. Linkerd does not include an ingress controller, right? Very specifically, we allow you to bring any ingress controller you want to that environment. Civo Kubernetes clusters, by default, when you install them, come with traffic. So I'm going to do a demo showing traffic, but we have examples using, emissary. I forget Glue's ingress. I think it is Glue, right? The Glue ingress from Solo. Nginx, emissary. I'm sure there are others that I forgot to mention. So that's the scene. The big part is we're going to talk about how and why. And luckily for me, both Sam and Kai kind of queued me up because I'm going to show some progressive delivery. And specifically, I'm going to show how you're going to use Flagger to do progressive delivery, how you're going to use a traffic split, and what happens when you do or don't add that ingress to your mesh. Sound good?
Sounds good. We've had a request. Could you zoom your screen so if possible to make your font a bit bigger? I don't know if the terminal's better now.
Yeah, sorry about that. Here's my Civo cluster, and yeah, please keep it up with those sort of comments. I'll try and keep things zoomed in. So here's my terminal. So this one's going to stay a little zoomed out because what I've got here is I'm showing all the pods in this environment, right? So what I have is Linkerd, right? The core service mesh that allows you to, get MTLS between all your applications and get all the other benefits of a service mesh. We also have a component called Linkerd Viz, which is our dashboard. So this allows you to pull up this thing, right? Which is a screen that gives you a view of your cluster, of your various namespaces in the cluster. It allows you to see for clusters that have pods that are part of the service mesh, it allows you to see the success rate of all the requests, the relative number of requests per second in the environment, and then the latency by latency bucket, right? So what's the, what does the tail latency look like on any given space? And right now I have an application. It's pod info. Right, it's running. I'm forwarding traffic to it. It's right now. I'm just hitting it over HTTP, but I'm going through the traffic ingress to hit this pod info application. And let me zoom in a little bit because we got some important info here. We got two things that we're going to control. Right, we've got the background color because we're going to do a blue-green deployment, and we've got what pod we're currently serving off of. And yeah, one last thing. All the things I'm going to be talking about are actually a reference to the Linkerd ingress docs page, which I'll also go put in the Slack, and which will explain in a little bit more depth what we're doing and why and how that works. So on to the actual demo. All right, so in the terminal here, this is the live traffic. I've got pod info running. I can see if I go look at the dashboard, I can see that, I've got the pod info namespace, got a couple components in this application. Specifically, I've got a little traffic generator that I built. I have a Nginx front end, which allows me to surface out my application. And then I have this pod info backend, right? This is the standard deployment of my pod info application. I can see requests, who's coming in. If I go look at pod info, this backend service, I can see that, the front end, Prometheus, the tap deployment, which is a component of Linkerd that allows you to see live traffic, as well as this unmeshed component called traffic, right? Which is our actual ingress in this Kubernetes cluster, right? So traffic is I can see what's coming in from it, but I don't have statistics. I also don't have an encrypted connection between traffic and pod info, right? So if I were in there listening, I could see the unencrypted calls between these two components. So first off, right, thinking about it as you're looking at Linkerd in your cluster, it's really valuable to just add that ingress to your mesh. So let's do that first and see what that gets us. So I'm doing a lot of copying and pasting here so I don't mistype. But what I'm doing is I'm actually grabbing the traffic deployment from the Kubernetes API. I'm going to output it as YAML, and I'm going to use the Linkerd CLI to add an annotation to this deployment. The annotation is just going to tell Linkerd to insert its little proxy, so we call it the Linkerd2 proxy, right beside that application, have it start handling the traffic from that ingress into my applications. So we see that kick off. I get a warning because I didn't create this in the same way. Obviously, we used Helm to create it initially. And we see the new traffic instance spin up. And now we're going to see is, I'm going to give it just 1 second. We're going to see inside pod info. If I go now look at the pod info deployment itself, pretty soon I'm going to see a new component pop up here, where instead of unmeshed, I'm going to see a little green bar saying, you've got successful traffic coming from traffic. I should pick a different word for it. Successful connections coming from our traffic ingress. We can also look at that by running the edges command. So Linkerd has this edges command, just tells you what deployments are talking to what. You can do deployments, pods, whatever. And whether or not they're currently MTLS. So I can see now traffic is talking to pod info, and we have MTLS over that connection. So let's go back to that dashboard and see, there we go. While I was talking, traffic came in. Now I'm able to see, like, of the calls from traffic, where they go, get full details on all those connections. That's really the excitement there. So right now I've got a lot of what I want, right? I've got MTLS from the ingress, like my gateway into that cluster, to my applications in the mesh, right? Which is pretty valuable. But what we're going to do now is we're going to do some kind of fancier stuff inside Kubernetes. We're going to talk about why you might want to change the way that ingress talks to the rest of your application. So let's do this. So what I'm going to do is I'm going to modify my customization file, right? So this is how I'm deploying pod info. And I'm going to add in this canary. So this is a Flagger construct. So Flagger's from the folks over at Weaveworks. It is, I believe, now a incubating product under the DevOps toolkit, right? The Flux stuff, if you haven't seen it. And if y'all are interested, happy to talk about that sometime. So I'm just saving the deployment, and then we're gonna reapply, right? So what I'm going to do here is I'm going to apply with a -K, which is customization. Right? I'm going to do a customization deployment of this pod info app, and we're going to add in Flagger to the environment, or tell Flagger to start controlling this pod info deployment. All right. So a bunch of stuff is going to happen. So if you look on the left, there are new pods getting created. There are going to be pods getting turned off. Right. So what happens is I tell Flagger to watch pod info, and what it's going to do is be like, all right, cool. I'm going to have 2 pod info deployments. One for my primary, where traffic's going to go the majority of the time, and one deployment that's only going to hold replicas or pods when there's a change going on, right? And then I'm going to create new services so that I can split traffic from one to the other, right? So let's look at our status. Okay, get canary. Here we see that my canary is initialized, so I've got new objects that got created. So let's check those out. Okay, get deploy. We see that when I initially built this thing, I only created one pod info deployment. It was just called pod info. Now I have two. I have pod info primary, which has 2 members or 2 pods, 2 containers, and then I have pod info, which now has none. Right, and that's because this flagger controller is taken over and is making some changes. I also have some services, right? So new services, I have pod info service, which is how I'm getting traffic to this application. And then I also have pod info canary and primary, right? And let's just do one more. Okay, describe traffic split. So this is that standard traffic split SMI spec that Kai showed you right before. So Linkerd implements the SMI interface for traffic split, right? And we do it specifically because that's how Flagger controls its canary deployments, right? So just to reiterate what Kai said, right? Like as you talk to folks that make tools that do cool stuff with service meshes, if you tell them like, hey, like we really like this service mesh interface, we'd like it to be portable, right? Like that's a great place to communicate stuff because it puts a lot of pressure on service mesh implementers to actually ensure that that's in there. Sorry for that tangent. So we've got our traffic split. And we can see that it's got a main service called pod info, and we're going to call it, if you look at our docs, it's called an apex service, right? But it just means it's really an empty service. And then there are 2 backing services behind it, pod info primary and pod info canary, and they've got a wait. So right now, all traffic's going to pod info primary. So let's look at that in a dashboard to try and make it look a little bit clearer. And other panelists, if there's anything you want to interrupt me for, if there's a great question I should hop on right away, please let me know. I'm happy to do that as I go.
Can I do that one right now?
Okay.
Okay. Ramiro has just asked, like, specifically, like, how much overhead to network and memory does running Linkerd in a cluster add? Is that a concern when deploying it, especially at scale?
All right. So I'll tell you, we believe that Linkerd is genuinely the most performant service mesh you've got out there. So the Linkerd proxy is unique inside the service mesh space because it is written in Rust. So Rust is a language that compiles in the native code, but like allows you to sidestep a lot of memory vulnerabilities. Anyway, long story short, you should check for yourself how heavy it is. We do have some benchmarks that we released very recently. So the folks at Kinvoke a few years ago wrote these benchmarks to decide like what was the most performant service mesh. And Kinvoke, you may know them from the news, they got acquired by Microsoft fairly recently. We went through and we reran their benchmarks earlier this year and here. So I did lie about the slides, right? But we ran the benchmarks earlier this year. They're open source, so you can go ahead and run the benchmarks yourselves in your own environment, right? But we found that Linkerd is really very performant. And the other thing to note, right, even though it comes with compute and memory overhead, right, what you get is you get other things that go faster. So if you're doing gRPC in your environment, right, gRPC does what's called, so Kubernetes does connection level load balancing. That means when you open up a gRPC connection, you get one long-lasting connection to one pod, and you send all your requests over that connection, right, which can actually get slow as you scale out. But if you're using a service mesh, it's able to do request level load balancing where it spreads that by request out to all the pods in a backing service, allowing you to go faster. So I know it's a bit of a Weasley answer. How much it uses is going to depend on your environment, but you're going to be able to see that very clearly inside your Kubernetes cluster. And then you'll find that there are performance gains as you add in a mesh depending on your use cases. Right, like if you're doing a ton of REST calls, well, what we're going to do is we're actually going to upgrade your connection to HTTP2 and then multiplex those requests, those REST requests, over that connection. So you're not building up a TLS connection every single time. You're maintaining one long running one, right? Which should, depending on, again, your traffic profile, could be faster than running it without. Did that answer your question? I hope it did.
He's commenting on YouTube, so he, I'm guessing he's a little bit delayed anyway. So we're going to assume that he is.
So here's our updated service map. So now that we've added in this canary, now we see that there's traffic going to two places, podinfo and podinfo primary. So let's look at podinfo primary. We can see that it's seeing calls come in from both its front end, right? So the standard way into this application. And I also made a special ingress just to demonstrate this thing where the traffic ingress is talking directly to this podinfo backing service. And we can see that traffic is talking to podinfo primary, right? Exactly what we'd expect. And again, we get all the metrics about that environment. So now I'm going to show you an intentionally broken demo, right? So let's do our blue-green deployment. So once again, I'm gonna change one of my files here. We're gonna go from blue to green, right? I'm a fairly literal-minded person. So we're literally changing the background color of the podinfo app, right? So what I'm doing is I'm running kubectl apply again on the customization that's defining this whole thing, right? But what I've done is I've changed the background color for this application. So we see two new pods are getting spun up, right? If you see here, there's 0 of 2 pods ready, right? So, or 0 of 2 containers inside the pod ready. So two new pods are getting spun up. And what's going to happen now is, let me just put this here, watch. What's going to happen here is we're using now a traffic split to split the requests coming into podinfo, coming into the podinfo service between two backing applications, right? Podinfo primary and podinfo canary. Making sense? Right, and so right now, 10% of the requests are going to canary, 90% are going to primary, and I also have another process in the background that is just spamming the ingress really fast. So what we should see, even though it's a low percentage of requests, what we should see is some of them are hitting podinfo canary, right? But we're not going to see that, and I'm going to talk about why here in a second. So with the traffic split going on, we see podinfo primary still getting requests. Oh, phew. See podinfo primary is still getting requests from traffic, right? Which is good. Sorry, let me get my laser pointer out. Still getting requests from traffic. If we look over at the traffic deployment itself, right, the ingress, we can see that it sees that it has two endpoints, right? Deployment podinfo and deployment primary, but it has sent nothing to podinfo, right? In spite of the fact that I'm currently looking at, about what, 40% of my traffic, zeros come through, right? If I look at the web page, I can refresh this all day long, and I'm staying on the blue background. Also, my pods are all going to be prefixed with podinfo primary. I don't see anything that just says podinfo, which is what I should see if something is being routed to the other service, right? So I'll just cut through and end the surprise here. What happens is an ingress by default, when you tell it to route traffic to a particular service, right? It doesn't actually send it to the service, like the cluster IP service inside your Kubernetes cluster. It instead evaluates the endpoints that make up that service and sends it directly to one of those endpoints, right? So you don't get Linkerd to do things like a traffic split or a service profile or anything like that beyond give you metrics, support tracing if you're doing tracing, or metrics, tracing, and MTLS. That's what you get out of that connection, which is for a lot of use cases going to be enough, right? So we often want the ingress to make the individual pod routing decisions, right? In this case, that's not going to work for us. So I'm going to show you what we do in this event if we want the ingress to talk to these service mesh constructs, right, on the way to our applications. Still making sense broadly? All right, and please don't hesitate to interrupt me if we've got other questions. So we'll let this deployment finish because I don't actually know how to interrupt it. I'm not actually that good at Flagger, I'll be honest. But we're gonna let it finish. We can see that as part of this canary, right, what it does is once it gets to the top, 75%, it's going to actually scale up that primary deployment. so that we have all pods now of the new type. So then we'll have 4 pods essentially that are all now with the green background. And so now if we go look at our app, we're actually going to start seeing some green, right? Because this is all the blue pods are getting turned off. And then once that's done, we're going to see 100% of the traffic shifts back to primary, right? It's great, but it's not what we wanted, right? We want the screen to change colors as we're looking at it. So how do we do that? All right, so what I'm going to do here is I'm going to re-inject my ingress, but I'm going to tell Linkerd that it's going to be in ingress mode. So this pod that we're injecting, or these pods that we're injecting, are going to be ingresses, right? And Linkerd needs to treat them that way. And what that means is now that it sees it, if it gets a request from that ingress with the appropriate headers set, right? So there are some Linkerd specific headers in the request. So if we see those requests, we're going to go ahead and transform them, right? So let's do that. So we see a new version of traffic spinning up, and we're going to look at that ingress object in a second, just so what I'm saying makes a little bit more sense. So I'm going to look at the actual ingress object that we're using here. Is this clear enough, or should I zoom in a little bit? Okay, so I've got the ingress. It's called test. I'm putting it in the pod info namespace, and what I want to do, right, is set the Linkerd destination override for this path. So when I see something come in on the slash path on this ingress, the root path on this ingress, I want you to rewrite the host, right, to tell Linkerd to send it to the service for pod info, right, not to an individual pod that the ingress controller is going to pick. And that's going to allow us to take advantage of that traffic split and that Apex service to route things around. All right. Oops, here we go. Oh yeah, and I want to show you the ingress documentation. So again, this is all detailed out like right here, right? So essentially what we say is in default mode, right, what we're not going to do is take over the routing, right? So if you have things like sticky sessions that you want out of your ingress controller, that's still just going to work, right? There's no change required. If you do instead put it in ingress mode, then all of a sudden Linkerd is going to take charge of that routing. So use caution and make sure that you're only putting this in the appropriate use case, right? All right, so we overrode that. So let's go ahead and once again, we're going to update that deployment. Now we're going to go back from, we're in green, but we're going to go to blue. So let's fix that. 1919 FF. All right, so once again, reapply, and we're gonna let Flagger take over. All right, perfect. We see pod info configured. We're gonna see here in a second a bunch of new pods get spun up. Right? Come on. There we go. I've had a lot of demos fail lately, so I'm on edge. But we have our new pod info pods coming up, and let's actually look at this. Let's actually look at this through the Linkerd graph. So we saw some failures from traffic. I guess something happened as we rolled out that deployment. It's fine, right? But it's good to know that as we did it, we had a bit of a hiccup from our ingress. But in a second, we're going to see a new deployment endpoint here. But let's look at pod info first. Just a quick heads up, and we've got some videos on troubleshooting with Linkerd. A quick view, an at-a-glance view of all your namespaces and the aggregate metrics by those namespaces can be really, really handy in diagnosing application problems, right? So I can see right away, okay, what namespace is having an issue and what is that issue. So let's go into pod info. I see now that pod info and pod info primary are both serving traffic. I can see the traffic split just like I was seeing from the CLI. I can see it here. I think if we refresh now a couple times, yeah, we're going to start seeing green, blue and green, which is what we wanted to see, right? There's some splitting. And if I now go look at the deployments, I can look at pod info, right? That canary, the one that's holding the pods for the canary service. And we can see that it's now getting traffic or it's now getting requests from traffic as well. And so that's how we override that behavior. So with the ingress, we're able to tell it to, instead of going to a specific pod, instead, overwrite that and go to the service, that ingress is referring to, and allow Linkerd to make those routing decisions, right? And it's not for every use case. You don't want to be using this all the time, but you want to use it in specific use cases. And some ingresses make it even easier, like Nginx has a native mode that allows it to skip picking the pod and instead just route to the Kubernetes service. So you don't even need to do that annotation. You can just take care of everything directly on your Nginx service. And then we'll have better recommendations with the folks from for Emissary. The Emissary ingress used to be known as the Ambassador API Gateway, as we've been working very closely with the Ambassador folks lately on integrating with Linkerd. So that's kind of the whole demo. I hope I didn't run too long there.
We have a couple of questions,
okay,
if you don't mind answering.
I would love to.
Yeah, so another one from Ramiro from YouTube, actually. Another question I've had for a while, is Linkerd an all or nothing on a cluster, or is it possible to do a progressive rollout where you only enable Linkerd in a few namespaces at a time?
Yeah, absolutely. So no, it's not all or nothing at all, right? And in fact, one of our getting started demos that we do very often just shows exactly that, right? Like how you can kind of bring it on namespace by namespace. And that's a really common story for customers that adopt us in production, right? Is you can just go through and start enabling one namespace at a time, ensuring that things work, rolling back if necessary and going through. So it doesn't create, like, let me just talk about CRDs really quick. Right, so let's do kget CRD. So we're going to look at the CRDs on the cluster, and we're just going to ignore, right, it's grep-v if you want to ignore. I just want to ignore cattle, right? Oops, I should have ignored cattle and flux. Oh, and flagger, whatever. There are two CRDs that I'm not going to keep doing that, extending my grep chain. There are two custom resource definitions that you get with Linkerd, because Linkerd by default uses native Kubernetes constructs. So we have this concept of service profiles, which allow you to get more detailed information about a given service, as well as configure things like retries, specific monitoring, bits like that. And then we have traffic splits specifically for this sort of use case, right, where you shift some percentage of traffic to another service.
Cool. Can I ask you more questions?
Please do. Yeah.
Yeah. So, well, a nice, fun one. Pratamesh asks, which command line bash tools are you using? It looks pretty with the Linkerd background image.
Oh, thank you. Yeah, so I'm using the Windows subsystem for Linux, right? Because I like to live dangerously. It actually burns me about once a quarter, but I really like it, honestly. I use the kubectx tools, and I think they're just wonderful. It allows you to switch between namespaces and context really easily. And I've started using this bash prompt modifier called Starship, which is just I'll tell you, I've been delighted ever since I started using it. But it does a great job of allowing you to modify your prompt.
Yeah, I'm a big fan of Starship as well. Andy, you've marked a couple of these that you would answer live. Should I leave them to you, or?
No, it was for the talk hosts to answer live. We'll answer them live rather than I will.
Excellent. Okay, so Vinay asks, in our environment, we're using Azure Application Gateway Ingress Controller. Can we use Linkerd?
Yes, definitely. So we'll work with any ingress, right? And Vinay, there's a ton of examples of folks using Linkerd on AKS, right? Like we use Linkerd on AKS as part of our product offering. Man, it works really well.
Cool. And then how about stateful application in K8s by using service mesh? Can it also help in increasing the performance, as Jason mentioned in the gRPC call thing?
Yeah, so it's going to depend on your stateful application. I'm just gonna be real. I'm going to talk about a couple that I know of real quick. So things like MySQL, Redis, Postgres, probably a few others, right? the way they work, right, is so with HTTP or gRPC traffic, we've got the client kind of initiates the conversation, we get going. Databases often do a thing that we call it internally server speaks first. So as the conversation starts, the server opens up the connection, and they're doing traffic over like their own kind of TCP protocol that they've got, right? And so what we do for that sort of stuff is we basically just treat it as a trunk, encrypt it, and allow data to flow, right? So I would say that in the case of your average database, you're not going to get a performance gain by adding Linkerd. What you're going to get is just that you're going to get TCP level metrics from those applications. You're going to get connection data that you can use, and you're going to get that certainty that you have it encrypted, right?
Cool. And then I think the one that you mentioned earlier from Ganesh. There's actually another question sort of related to from Ganesh as well of like, so the original one was why Linkerd over Istio, and then why Linkerd doesn't use Envoy, and how do things like rate limiting work, and is there a plan for Linkerd to use Envoy?
Yeah. All right. So obviously, it's probably pretty clear that I work for Linkerd, right? Or I work for Buoyant, the company that makes Linkerd. So please treat my statements with a grain of salt. I can tell you from the folks that I've talked to, right? Like the thing that people like about Linkerd is it's very performant, it's very simple, and it's very easy to understand, right? And I think depending on your use case, like you're gonna have to pick a mesh depending on your use case, right? Like if you're writing a custom WASM plugin to sit beside your application, then like you need an Envoy-based mesh because that's what it's going to do for you, right? And if you're going out there and you're like, man, I want to configure a service mesh and also debug Envoy filter chains, right? Great, like that's Istio's the tool for you, right? With Linkerd, right, like you're not really going to have to learn about the Linkerd proxy because the Linkerd proxy is just an implementation detail in Linkerd, right? We think that one, by being written in Rust, right, we keep the Linkerd proxy like the most secure proxy that you can get out there, right? Because we're able to sidestep a lot of memory management vulnerabilities that you get in C and C++, right? So when you consider, right, like if you're a bank, right, or if you're a healthcare institution, or if you're anyone that has critical data, right, that proxy is sitting beside every single application in your Kubernetes cluster, handling every single bit of sensitive data that transmits it, right? So if you've got a memory management vulnerability that you don't know about, right? Like that's a scary thing, right? And so we think that we reduce the odds of that by using Rust and by doing the testing that the CNCF allows us to do, right? But that's like a judgment question for you, right? I would use Linkerd if you're looking for something simple. You're looking for the basics of a mesh: observability, security, reliability, right? Then it's in my mind the right tool for you, right? But if you have more complicated use cases, then look for other meshes. And obviously, don't take my word for it. Trust your own judgment. And then why we don't use Envoy? Actually, it's a feed into that exact same question, right? So when we wrote Linkerd, right? Well, not like I was there, right? When the folks at Buoyant wrote Linkerd initially, right? They looked at Envoy as the proxy, right? Because Linkerd went through this big rewrite at one point, and so they looked at Envoy, right? And the concern was it would be difficult to adhere to our design principles of being extremely lightweight and being extremely easy to use with Envoy, right? Like Envoy is a great proxy, and I'll tell you all day to go check out that emissary ingress from the folks over at Ambassador because it is amazing, and it's got a ton of powerful functionality that you get out of that Envoy proxy, right? But that Envoy proxy can also be a huge source of complexity, and when you sit it beside every single application in your environment, you don't just have to become an expert in your service mesh. You have to become an expert in your service mesh and in that proxy, right? Which may or may not be valuable depending on your use case. I hope that answers your question, Ganesh. And I don't have bad things to say about Envoy, and I don't have bad things to say about Istio, right? Like they're both great tools.